Algebra 2 students. I hope you're all doing all right as we start week 4 here of distance learning. We're going to try something different today where we kind of embed your questions and assignment within the video that you're going to be watching. This is Miss Huss here, by the way. And so let's just give it a practice. Answer the question that pops up on your screen and then go ahead and hit next and the video will keep going. Okay, so we're going to kind of leave stats behind here. We kind of wrapped that up last week, and we're going to start talking about how to simplify expressions in this week. So we're going to do that by reviewing some exponent rules that you might already remember from Algebra 1. But if not, this video will kind of walk you through it. So there is a note sheet that's posted in Classroom as well. You need to either print that or find a different sheet of paper that you can kind of follow along as we work through this, okay? I want you to be writing stuff down with me as we do this video. So, here we go. We're going to start by, you're going to see the essential question up at the top says, what are the exponent rules that we need to be able to simplify? And how can we use simplification to write equivalent expressions of exponents? We're actually not going to talk about roots here, just the exponents. So, there are going to be 3 rules that we talk about today, and you're going to be using the idea of taking an exponent problem and expanding it out to come up with what those 3 rules are. If you kind of understand where they come from, I think it'll help you understand the rules. So, really exponents are just repeated multiplication. So if you look at the example here in this table, we're trying to simplify the problem x to the 3rd times x squared. So x to the 3rd is really those first 3 x's repeatedly multiplying. X squared is those next 2 x's multiplying. And so that expansion is really taking those exponents and just writing out the long multiplication that goes with them. And when I simplify that, I'm going to count up how many times I'm repeatedly multiplying x together. And that's going to give me that answer of x to the 5th. Now, here's what you're going to do. You're going to, there's going to be a question that pops up. Before you answer that question, I need you to fill out the rest of this table. So if you need to hit pause quick, go ahead and do that, but you're going to fill out the rest of this table, expanding out those next 4 problems, and then simplifying it down to just one expression. So hit pause, do that, and then answer the question before you start watching again. Okay, so we're going to talk about what you got on your table for all of these questions, or for all of these like simplifications here. So you expanded out your f to the 6th times x to the f to the 5th, and then if you count all those up, there should be 11 f's repeatedly multiplying. I do it with these y's. I have 8, and then I have 2, and then that gives me 10 total. Notice here that that D up here had an invisible 1 that I didn't write, but I added it in. Anytime I see a letter that doesn't have an exponent, I like to write that 1 in to remind myself that there is 1 D there, not 0 D's. And so I wrote out 3 of them and then 1 and counted them up, and that gave me D to the 4th. And then this time you had to expand 3 different sets of x's, 2 and then 4 and then 3, and count all those up, and there's 9. So if you notice, all these problems started out as multiplication problems. You had x to the 3rd times x squared, f to the 6th times f to the 5th, and so on. But I want you to stop and think about what is a rule that we could write that would get me from the top problem to the bottom answer without having to write out all those expanded forms, because you can tell it's going to get kind of annoying to have to always write out those expansions. You can, but then you're just going to be writing a bunch of things over and over. And what if I asked you to simplify like x to the 80th times x to the 34th? You don't want to have to expand that out. You want a rule for it. So you're going to pause and answer this question down here. How could we get from the top multiplication problem to the simplified answer without having to expand it out? So how did I get from the top to the bottom in all 5 of those problems? What did I do to the exponents? All right, and the rule that hopefully you found is that you added the exponents. If I add 3 and 2 in that first problem, it gets me 5. If I add 6 and 5, it gets me 11. So even though these are multiplication problems, the quick rule is to add the exponents. And we call this the product rule. The names here are going to come from how the problems look at the beginning. Product means multiply, and those problems are all multiplication problems. All right, let's do the next rule. So the next rule, you're going to see that you start with a problem up here that says r to the 9th divided by r to the third. We expanded it out by writing out 9 r's on top and 3 r's on the bottom. Again, those exponents are just repeated multiplication. Now, I circled, or tried to, an r over r, and then I wrote it over here. I want you to think about what is r over r. If r was, say, 2, what's 2 divided by 2? Hopefully you just said 1 to yourself. If it's 8 divided by 8, that's also 1. And so whatever r is, if it's r over r, that's going to divide to be 1. And so what that means is I can take all the pairs that I have of 1s and get rid of them, because something multiplied by 1 is just itself. If I do that here, I'm left with 6 r's left over, and so I can write that answer as r to the 6th power. So you're going to fill out the rest of the table. Pause, exactly as what I just did in that example. You're going to expand out all the letters on the top, all the letters on the bottom, find all your 1s to get rid of, to cross off, all your big 1s, and then you're going to write how many of that variable you're left with. So go ahead and fill in the rest of that table. Okay, so here, I'm just going to go over the answers you should have gotten. So on that first one, 8k's on the top, 5k's on the bottom, you're left with 3 over, so k to the third. Here I had 3 b's on the top, 2 b's on the bottom. I crossed out 2 sets of 1, and I'm left with just 1 b. Here I've got 7 m's on top, 2 m's on the bottom, and I crossed out the 2 on the bottom because they were giant 1s, and I'm left with just 5 m's. And then on the last one, I have 6 x's on top, 4 x's on the bottom. I have 4 1s of x's that I can cross off, and I'm left with 2 over. So again, I want to try to find that rule that gets me from the top division problem into the simplification without having to always do that expansion. So you're going to try and find that rule and describe what it is. What do you do with the exponents when you're dividing 2 bases that are the same? What do you do with those exponents to get to that simplified answer? So hopefully that you realize that you wanted to subtract those. Again, the name of the rule comes from how the problem looks at the beginning. When I'm dividing 2 things, a fancy word for division is a quotient. And so we call this the quotient rule. The rule is to subtract your exponents when you are dividing. The last rule we're going to talk about, you're going to see that you have some sort of expression in parentheses here, and then an exponent on the outside of the parentheses. You're going to have to do expansions here in 2 steps. So the example problem you have here is 2x squared, and then that's in parentheses with the squared on the outside. So you're going to first take the exponent on the outside and expand to that many sets of the expression inside the parentheses. So here that 2 on the outside means that I had 2 sets of 2x squared. So I wrote that out first. Then I took both of those sets and expanded them further. So I have a 2, and then I have an x squared, which means x times x. I wrote that out for both of those. And then I'm going to multiply those normal numbers. I'm going to multiply 2 times 2. That gives me the 4 down here in my simplified answer. And I count up all my x's. That gives me x to the 4th. So you're going to do the same thing. You're going to expand in 2 steps. And then write what your simplified answer would be. A couple of them aren't really set up super logically on the bottom, like this third one. We'll have an A and a B, and we only gave you the A, so just know that you'll have to add that as well. So pause, fill in the table, restart. Alright, so you expanded this one, 2 sets of m to the third, and then when you expanded out each of those m to the thirds, there are 6 m's there. Here, I have 5 sets of a squared b, and then I wrote out all of those, and I ended up here with 10 a's and 5 b's, repeatedly multiplying. And then I expanded out my 3 sets of x to the 4th, wrote all those out, and that gave me x to the 12th. I expanded out my 3p to the 6th, I had 2 sets of that, and then I expanded it all out. Notice that when I multiplied 3 times 3, that gave me 9, not 6. You're multiplying here. And then I have p to the 12th. This is probably the toughest rule to figure out what's happening to get you from the top to the bottom, but see if you can figure out how would you get from that top original problem with an exponent in parentheses to the answer without having to do that expansion. So look for some patterns there. Okay, hopefully you notice that you were distributing or multiplying that outside exponent to each exponent inside the parentheses, including any invisible ones. Here I want you to notice, probably you came up with the idea of multiplying, but I want you to notice here that I didn't multiply like 2 times 3. I really multiplied 2 times an invisible 1 exponent, and I do 3 squared, which is 9, not 3 times 2. So be careful, you're distributing the power on the outside to the exponents on the inside. And this is called the power rule because you have a power outside of the parentheses. All right, here's what we're going to do. We're going to take these 3 rules. You're going to flip your sheet over or scroll down if you're looking on your computer, and you're going to try these 8 example problems. I want you to try them on your own first, please, 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 because you will learn a lot more trying them and making mistakes than you will if you just wait for me to show you how to do it. So, here's my advice for you. You want to start with a power rule first if you have it. Just like in order of operations, you start with parentheses. Here you want to do the power rule first. So if you have parentheses, you want to distribute that exponent on the outside to every single thing inside before you try to do product and then quotient. Okay, so try to look in the front and do your rules in that order. I'm going to have you pause, try all 8 of these problems, and then I'm going to go through them super, super quickly. Don't worry, you'll get a chance to practice some more tomorrow and Wednesday. All right, here we go. So let's just go through the answers quick here. So here you distributed with the power rule that squared into both the 4 and the m. Make sure 4 squared is 16, not 8. It's not 4 times 2, it's 4 squared. B, you have 3 p's on top, and then you have 6 p's on the bottom. There's no power rule here, so I started with that product rule on the bottom. And then if you subtracted those, you might have ended up with p to the negative 3. That's okay from now. We'll talk about the negatives tomorrow. Or you notice that you had more p's on the bottom than on the top. If you cross out all the p's you can make 1s out of, you have 3 left over, and those 3 are left over on the bottom. Next, if you distribute that 3 into each of those, you get 8, a to the 6th, b to the 9th. Remember, 2 to the 3rd power is not 6. It's not 2 times 3. It's 2 times itself 3 times. So 2 times 2 times 2 gives me 8. On the next one, straight up just product rule, putting those m's and n's together. Noticing that m that's in the second part of that expression has no exponent, so there's an invisible 1. And so you have 3 m's and 9 n's. Here's where it starts to get trickier on E and F especially. You want to start by distributing that 4th power to every single thing inside the parentheses. So I have 3 to the 4th, x to the 8th, y to the 4th. I would type 3 to the 4th into my calculator, and then that gives me 81. And you're going to notice that you have 12 x's on the bottom, 8 on the top. So if you think about, you can cross 8 of them out, and then you're left over with 4 x's on the bottom. Letter F. You had to do a lot of distributing here. 2 to the 3rd, x to the 15th, 5 times 3, y to the 12th, and then 8 to the 3rd, x to the 3rd, and y to the 9th on the bottom. You want to simplify that fraction. That 2 to the 3rd over 8 to the 3rd is 8 over 512. If you left it like that, I'm fine with that for today. I can simplify that though. If you type in 8 divided by 512 in your calculator, and then press math, enter, enter, it'll reduce that fraction to give you 1 over 64. And then I thought about crossing off all the x's and y's I could, or subtracting using the quotient rule. 15 minus 3 gives me 12 x's, and 12 minus 9 gives me 3 y's. G, you're going to do the power rule first to get x to the 10th, and then x to the 10th times x to the 3rd gives me x to the 13th. On H, I did all my product rules first, and then quotient, subtracted the 7 minus 2 for my A's and the 3 minus 2 for my B's. If that felt fast, try watching it again maybe, and again, you'll get more time to practice, so don't get overwhelmed here. You probably made some mistakes on the back, and that's fine. We're still learning. You're going to be okay making those mistakes. Hope you all are doing okay, and we will give you some more tomorrow. Bye, guys.